All right. So who can tell me what are you doing to figure this out?
Multiply 1,500 by 0.09.
And then do what with that number?
Subtract it from the total. So 135. Subtract 1,500.
So yeah, 0.09 times 150, 135. I like it. So 1,500 minus 135. So the sale price.
1,365.
All right. Is that cool? I mean, this is you got to know how to do that because this is living in the world and buying anything. You got to have an idea of how to do this. If I would have said mark it up, it would have just been plus here, right? That would have been the only difference, but the same setup and everything. So, what do I do a problem algebraically for then? Is when I don't know this, I know this. So if we know this, I see what to do to figure out this. If I don't know this, then of course we're going to call it X. Now let's say I take 9% off. And I know, let's say the sale price, I know the sale price is, what you got, Jeff? I don't know, man, leave me alone. Maybe make something that actually works. Let's see if I can do this. I lost it. Darn it. I think this will work. 1274. Let's see if that's right. Let's say I know the sale price is 1274, but I don't know what the original price was. The power of algebra is you know what to do if you knew what this was. You know what to do then. So pretend like you know what this is. Say it's X. So how do I take 9% off of this? Same way we did there. What am I going to replace with X? What is it that I did know that I don't know now? So what's this equation going to look like now? And when I knew it was 1,500, it was 1,500 minus 9% of 1,500. So now I know it's X. So it's going to be X minus 9% of X. I mean, this is the thing that students don't seem to grasp. You do the same thing with the X that you would do with the number if you knew what it was. You have to, because that's all X is. X is the number. We just don't know what it is yet. But that means I can do everything I would if I knew what it was. I could do everything I would have done normally. That's the real power of algebra. But I know the result of this is supposed to be what? What's the result of this supposed to be? The sale price. So it's a whole X minus 0.09 of an X. This is another place where we freaked out. How do I write 1 so I can take 0.09 away from it? I have to write it as 1.00. Do you actually have to do that? You shouldn't have to do that. If I have $1 and I have to pay you 9 cents, how much money will I have left? Please say the number. $5 and I pay you 9 cents. How much money do I have left? 91 cents. You guys can see how that's the same problem. 1 whole minus 0.09 of that will always be 0.91 of it. A whole dollar minus 9% of it, 9 cents, is 0.91. Right? So I got 0.91x. And then how do I finish solving this? Divide. So if yours said mark up, you just put a plus there. That's all. That's the only difference. Some of you guys had said discount. It's a subtraction. Some of you guys said I marked it up. It's an addition. It's the only difference. And when I divide by 0.91, did I do this right in my head? You get a nice number here? I'm okay if you don't. Nobody's going to do it for me. All right. 1,400. Oh, sweet. I did it right in my head. So the process is exactly the same if I know that number or if I don't. It's just that here I didn't know the final thing. Over there I knew the final thing, so it's actually a little, now I've got to solve for the original thing. I have to use X in there because I don't know what it was. So that's number 5A, right? That's the kind of thing, just like 5A. Nobody had that problem, but everybody had that problem. Yeah. Sorry, which one? The bonus? Oh yeah, I like this. I like it. Since you only have one shot at bonus, and since you're going to take a makeup test, you're not going to get the same questions. I can look at this here. The first bonus was this. 1, 2, 3, 4, 5. Was it plus y in there? No. Plus y, plus y, plus y. 1, 2, 3, 4. 1, 2, 3, 4. Is there any multiplication happening up there? What does multiplication look like? So is this multiplication? No. Is this multiplication? Yes. So is there anything sitting next to a parenthesis? No. There's a minus and a plus in between everything. Nothing is multiplying. That's number one to realize. Nothing is multiplying. Number two. If I gave you this problem here, where would you start? What's the very first thing you would do in that problem there? Very first thing you would do. Good. Right? It's like Russian nesting dolls. You ever seen the Russian nesting dolls? You actually, with math, we started the inner one first somehow. We're magic like that. So we started the very innermost parentheses. Because you got to do what's in here first. And in here, you got to do what's in here first. That's why you always go to the innermost parentheses. So what's the innermost parentheses here? Can't do shit with that. So then you bring the negative through. Combine like terms. Bring the negative through. Combine like terms. Bring the negative through. Combine like terms. It's a bonus. I can do whatever I want to in bonus. This wasn't that hard of a bonus, though, really. You just had to be a little disciplined about start at the innermost, bring the negative through. So this little piece here now looks like this. So that little piece there is now 2y. You guys see that? So now this piece is going to be, let's see where I'm at. X minus 2y plus y. You just keep working out like that. Just keep working out. Is that cool? So that's bonus number one. Bonus number two, I don't think anybody got that one right. I got a lot of x less than or equal to 0, but that can't be right. That can't be right, because negative 1 is less than or equal to 0, right? Negative 1 squared is 1, which is not. So that can't be an answer. That can't be the answer. In fact, is this possible for real numbers? Is that possible? Is that possible? Can you square a real number?
0?
Huh?
Only for 0, right?
No, yeah, but see, even 0 wouldn't work here, right? So there's no real number that'll make this come out to be negative, of course. You can't square a real number and have it come out negative. Is that cool? So I'm with you. So now we'll get back to the original problem. You can make it equal 0 only if x equals 0. That's the only answer. That's the only way to make something squared less than or equal to 0, is to make it equal to 0. It can't be less than 0. I would have accepted complex answers maybe, if you know what complex numbers are, but that was more than I really wanted, just real numbers. Cool. Okay. Number 3 in the bonus, a decent little chunk of people got that one right. It wasn't really that hard, but you just had to give it a try. Cool. Anything else from the test or the grade sheet? I'm trying to remember it. Yeah, I was kind of disturbed at how many people missed the slope question. What's the formula for slope? I mean, in English it's rise over run. What is it in Mathish? Well, when you rise, what axis are you going along when you rise? In fact, what does it rhyme with? Y's. So a few people have this turned upside down. Some people mix the X's and the Y's together. But it's the difference in the Y's over the difference in the other guys. Just to keep the rhyming going. Alright, this should be a part of your physical being, is this formula. Right, it's the difference in the Y's divided by how far did it change in this direction divided by how far did it change in this direction. That's going to be the slope. Cool. So that was for number 7. Number 6, a few of you guys didn't know what a table of values meant. It's troubling. But, and it's not a line. How do you know from the beginning that's not a line? The one I gave you for number, I forgot what it just said.
Squared.
Number 6? Yeah, it's squared. So some of you guys, well, everybody had something that looked like this, nobody had this. So I told you, use these values. So some of you guys have said use from -3 to 1. So those are your inputs. Now just input them and see what comes out. Then you get a collection of points to graph, and then you connect the points. So a lot of you guys did something else than this. But this is all I meant. You make a table of values. That's the most basic way to graph anything, is to get some points that are on that line, or on that curve in this case. So that's number 6. You just had to do. So some of you guys have said start here. Some of you guys have said go from -2 to 2. Some of you guys have said go from -3 to 1. It all depends on what kind of. I was trying to help you get the best points to graph those things. Let me see. What's the equation of the line that we know so far? We're going to learn a new one today. What's the equation of the line that we know at the moment?
Y equals fx plus g.
Of course, this means the slope, and this means the y-intercept. So there's that one of the last problems that said, find the slope and the y-intercept. A lot of you guys found both intercepts. I didn't ask for that. It said find the slope and the y-intercept. And how do you do that? You solve for y. No matter what I give you, if it's a straight line, it almost seems like magic on one level. You just solve for y, everything, all the numbers just fall into place. And we talked about why that makes sense. Why the number here is the slope, why the number there is the y-intercept. So if I gave you this equation, what's the slope?
2 over 5.
Yeah. What does that mean?
Rise over 1.
Yeah, so you rise 2, run
Over 5.
5. I like it in the positive direction. I like it. And the y-intercept is going to be what?
-4.
And this is where I get to be, you know, I'm a math teacher, I get to be a picky dork a lot. But a y-intercept is a point. So then I just plot that point, and you do what this says to do. You get another point, and then you must connect them, right? I did. You got many of these guys. All right. Anything else from that test? So don't forget you can make corrections like always. Anything you haven't corrected yet, you can still turn in. Just the later it is, the less points you could get back. You can never get below what you got in the first place. All right. So we're going to get into some kind of new stuff. Hey guys, hey. All right. Today I get to talk to you about drinking beer and then taking a test. We're not going to actually do this. This is not an experiment that I'm suggesting you follow. But we're going to get into something known as correlation. Right, so let me start out with a kind of a silly example of correlation. Then we're going to take a step back and talk about another equation of a line, and then we're going to come back and see how this relates. If I were to watch several basketball games, if I had no idea, if I was an alien and I come down and I watch some basketball games, I might say, all right, so playing basketball makes somebody taller. And why would I think that? I'm sitting in the stands and I'm looking around at the people watching the game, and they're all much shorter than the people on the out there playing the game, right? On the court. So there is a connection between height and if you play basketball or not. Is this correct? Is this correct? I mean, now the mistake people make, I saw the little look in your eye, is the same mistake people make about conditional probabilities. If you get off of a Harley-Davidson motorcycle, there's a higher chance you're a man. It doesn't make the probability you're a woman go to zero. It just changes that probability. So is there a connection between the height of a person and if they're a professional basketball player or not? If I tell you I got a professional basketball player coming over tonight, what do you see in your brain? Somebody tall. They're going to have to duck to get through my freaking front door, aren't they? I'm thinking tall person. Now, Spud Webb, anybody know Spud Webb? He was like 5'7", and he was dunking. He always gave me hope, right? But no, I didn't know. It just didn't work out. Got to lower that thing. So there's always going to be outliers. There's always going to be somebody that doesn't follow the general pattern. But there will be a general pattern. So another example is if I plotted energy use during the year versus the temperature. I kind of did the picture automatically in my head. But when it's really, so at the beginning of the year, it's kind of colder. So you think energy use will be high. And at the end of the year, it's cold again. And in the middle of the year, it's the summertime. Are you guys kind of with me? So maybe in the spring it'll go, and then it'll go back up, and then go up again. So maybe it looks something like that. So there is a connection. There's a correlation between the temperature outside and the energy use in the households. That just makes sense. But now I can talk about the mathematical connection between them, and then I can try to plot actual data values, and then I can make a prediction for next to see how much load there's going to be on my system, for example, so there's no rolling blackouts or brownouts. You guys, that seems like a good thing for California to look at, is to know ahead of time, can I predict how bad it's going to be based on how it's been in the past? Cool, I like it. Maybe. Yes? No? A little bit? All right. So what we're going to do eventually is we're going to have these points plotted, and we're going to try to figure out what's the best fit line. So if I had these points here, the best fit line is going to be kind of like a graphical average of those points. I'm going to draw a line that averages where all those points are. And I showed you an example of this when I showed you that plot of your homeworks versus your grade. I did it again, but I just didn't feel like printing it out because I'm like, I keep saying the same thing over and over. Do you remember this? There was the little blue points that showed the homeworks you did and what your grade was, and there was a connection between the two, like we would expect. The more homework somebody did, the higher their grade was. Does that mean that homework made their grade higher? Not necessarily. Good students just do their homework. They also do other things that are smart, right? So of course their grade's going to be higher, but I would still do more homework. There's probably some kind of an effect there. Are you guys with me? So here, if I try to draw a graphical average, maybe it'd be like that. I'm trying to average where all the points are. So that's that line I showed you with the homework grades. I try to average where the points were. So we're only going to talk about linear correlations. What kind of correlation would this be? This looks like, wow. Oh, it's kind of freaky. But some kind of polynomial, some kind of very curvy thing, maybe even like trigonometry stuff. Oh shit. We're not going to deal with that. Don't worry. We're going to deal with linear correlations. So that brings us back then to lines. So we got to talk a little bit about a different way to look at lines. What if I don't know the y-intercept? What would I do then to get the equation of a line? So for example, if I knew that I have a line going through 2, -5, and what you got, Jeff? 5, -1. And I want to find the equation of the line. Why does this equation not help me? What can I calculate from those 2 points that will be good for this equation? What can I calculate from those 2 points? Slope. I need the slope for this. But what can I not get from those equations?
Y-intercept?
Yeah, they didn't give me the y-intercept. There's no 0, comma something, so I don't know what the y-intercept is. So there is a different formula for the line. Now let me try to show you where it comes from. It's an additional line formula. It's not better than this one, it's just another line formula that I can use. So, let me show you where it comes from. And then we'll try to use it in a few situations. And then we'll go from there. So this is true. There's no just, if I have a line, this is true. This is the definition of what the slope would be. Is that cool? You guys just don't want to give me anything. Is that understood? Am I using the word cool and you guys are like, that ain't cool, Jeff, but it's understood. Okay. What do these little subscripts mean? What do the little subscripts mean? The subscripts, the 2 and the 1, what do they mean?
For the 2 different points.
Good. I love it. Savannah, do me a favor, move up here. Right? So I got 2 different points. So if I pick, does it matter what points I pick? Does it matter what points I pick on the line? Would it change the slope if I pick 2 different points? So if I have a line that exists. Here's the line. If I pick x1, y1, and x2, y2, I get the slope, right? Did it really matter what point this was? If I pick a different point on the line, will I get a different slope? If it was a different slope, what would that mean? That I'm suddenly turning some other direction. Then would it be a straight line then? Would it be a straight line if it turned? No. So does it matter what 2 points I pick on the line? Will it change the slope? No. So what we do, to develop a new formula, we don't make this other point something specific. We just say it could be any point on the line, x, y. Any other point on the line. No subscript means it could be any other point it wants to be. It doesn't have to be a specific value. That doesn't seem like a huge step, but it is. When you see a subscript on something, it means it has to be a specific thing that you were given. When there is no subscript, it could be any damn thing on that line. So this is seems like it's not a big step, but it is. So now I can write this as y minus y1 over x minus x1. And then I can just multiply this bottom up here. Is that cool? If I don't like a fraction, I don't like this fraction, let me just multiply the bottom up. So then I end up with this equation. So this equation, to use this equation really directly, I have to know the slope and the y-intercept. To use this equation, I have to know the slope and any other point on the line that I want. Any point. Doesn't matter. Doesn't have to be the y-intercept because now I have a place for the x piece and a place for the y piece. This only has a place for the y piece of the y-intercept. So this is a little more general and a little more generally useful. So let's do this example over here. Take a minute and figure out this guy's slope. Just figure out this guy's slope first. Alright, so how do I set up the slope here? What did you guys do to get the slope? What do I put on the top there? There's two different ways to do it, really. Well, set it up for me. What did you put on the top? Yes, you could do -5 minus -1. Remember, my suggestion was to do like this. There's got to be a minus in the equation, and then it's -5 minus -1 over. Now I've got to do the same direction, 2 minus 5. So what do you get there? You get -5 plus 1, -4 over 2 minus 5. I get 4/3. So the slope is 4/3. So that's like that problem on the test. That should be a problem. You're like, give me plenty of those. Give me a lot of those, Jeff. I can freaking subtract and reduce. Now, do I have a point? Sometimes. Do I have a point in this problem? Yeah, I got 2 freaking points. You can pick whichever one you like. Which one looks better to you? Which one do you like to look up better? This one? Ah, sure, what the hell, right? This guy looks shifty. So I like 2, -5. So I got my slope, check. I got my point, check. So this would be x1, and this would be y1, because that's the one point that I'm going to use. It doesn't matter which point you pick. In fact, we'll pick the other point next to show you that the equation comes out the same. It shouldn't matter. What do I need for a line? I need a beginning place and a direction. And then that'll give me the whole line, right? So who cares if I use this beginning place or another point on the line or another point on the line? It's still going to give me the whole line. I like that. That's the whole idea behind this. I just need a point to start off with and a direction. So I can go up and over, down and back. I get the whole line. I don't care which point you start at, you still get the whole damn line. So now I just got to plug and chug. So these are x1 and y1. Bam, bam. This is... So it's M. Cool. So I get y minus what? What's the y piece? -5. Equals the slope times x minus what? The x piece, I love it. 2. Oh, you're going to like this. You would put a fraction in there, Jeff. Yes. You know me better. So I get y plus 5. What can I do on that side? Yeah. 4/3 x minus 8/3. I like it. And then I can get y by itself. I'm trying to make it look like this. This is in general, that's a better form because it's a little more simplified, right? So we pretty much always want to bring it back to mx plus b form. So what do I do to get y by itself? Subtract 5. And that'll be 5 over 1, right? Which becomes what over 3? I got to put it together with this, so I need LCD. So what's that become?
15.
Negative 15 over 3. I like it. So negative 8 and negative 15 is?
7.
Negative 8 and negative 15?
20.
You owe $8, you owe $15. Overall, you owe $23, right? Two negatives stay negative when you add them together. You can't cancel debt out that way. I've tried. It just keeps getting bigger, stupid debt. So let me do two things. I know you guys don't like the fractions. Too damn bad, right? Fractions just show up in real life. It's just too damn. You got to work with them. This line, well, number one, how do I check this line? What point did I not use? This one, right? That's supposed to be a point on the line. So what's this point supposed to do? What's that point have to do if it's going to be a point on the line?
That's right.
That point has to... That point has to do what?